Hey guys, we're going to talk about asymptotes. What asymptotes are is our graph grows and then there's like this invisible wall that is stopping it and it's just going to keep growing up or it's going to flatten out. These invisible walls are called asymptotes. So a vertical one would be the wall going up and down. So how we find those is, let's say they gave us x over x squared minus 9. The first thing I'm going to do is I'm going to factor out the bottom the best I can. Because if I were to FOIL this back, I'd get x squared plus 3x minus 3x. Those would cancel, and then 3 minus 3 gives me to negative 9. Then I'm going to set my denominator equal to 0. And then I'm going to solve. So x equals negative 3 and x equals positive 3. So on my graph, I'm not quite sure what this creates, but I know at 3 there's some invisible wall, and then at negative 3 there's some wall with our graph doing something on either side of it. Okay, another example could be x plus 3 over x plus 3, x minus 3. So because there's an x plus 3 on both top and bottom, I can cross those out. And then since there's nothing on top, it's just 1 over x minus 3. Now I set this equal to 0, and I solve for x. So again, I'm not quite sure what my graph does, but I know at 3, there's some kind of wall preventing it from going that direction. Okay. Then let's say x plus 3, x squared plus 9. I can't factor this any further, so I'm going to set this equal to 0. And because the square root of a negative is imaginary, that means that there's no vertical asymptotes. So our graph has nothing stopping it from going up or down. Okay? Horizontal asymptotes, what we do for those is there is going to be a fraction given to us with some number on top, some number on bottom, then x, then x. It's going to have some kind of exponent and some kind of exponent on the bottom. Okay? Just like we did here, there's a 1 here and a 2 here. Okay? If m is equal to n, our horizontal asymptote is a divided by b. Okay? If m is less than n, then our horizontal asymptote is the number 0, or y equals 0. Okay? And then if m is greater than n, our horizontal asymptote does not exist. Okay? So for example, let's say I have 2x over 3x squared. Okay? M is greater than n in this situation. M is greater than n. Or, sorry, m is less than n. Okay? So 1 is less than 2. So that means that the horizontal asymptote is 0. So for this graph, our graph can get super close to the y-axis, but never get there. Then for another example, let's say I have 2x to the 5th and 3x to the 5th. It doesn't matter what we're adding to it after that. All we care about is this leading exponent. So they're the same. So that means that our horizontal asymptote is 2/3 because of these numbers in front. Okay? And then if we had m to the 5th over x to the 4th plus x to the 3, blah, 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 blah. Because 5 is bigger than 4, that means m is greater than n. We're going to say that there's no horizontal asymptote. Okay? And then the last thing that we're going to work with is holes. So let's say x plus 3 over x plus 3 x minus 3. So remember how we canceled these out to get 1 over x minus 3, and then we found our vertical asymptote to be where x is positive 3. Okay? This is still a vertical asymptote of sorts. So this is still an x plus 3 is equal to 0. We solve. But what's happening is we're having a graph that's going to be continuous here until we get to 3, and there's going to be some kind of wall. But because it's continuous with only one exception number is this negative 3. So there's a hole right here. So it's going, stopping, and then continuing its movement right here for the hole. So if we have a top and bottom that match, and we cross them out, we still solve for the vertical asymptote of it, but it's not a vertical asymptote. It's a hole.